Let's attempt this Wireshark quiz and let's see how you are. And learn anything that learn according based on this quiz. Learn by doing quiz to fill the gaps. And I have opened the Wireshark here, and this file is tutorial.pcap, which is downloaded from sample captures. So we use this as a reference and to understand to answer this quiz. And what is the first question here? First question is, which of the following is not a HTTP response code? Remember when we learned there are error codes for the HTTP that are from 100 to 100 plus that are informational, 200 plus are success, 300 plus, 303 excess are for redirectional, and 400 plus are client error, 500 plus are server error. But whereas 600 are is not a valid response code for HTTP, but which is a valid code for a SIP protocol. Okay, so it is not a valid HTTP response code. So can Wireshark can capture on multiple NIC. What is the NIC stands for network interface controller or an interface. So what is the answer? True or false? How do you capture? If you go to Wireshark, yeah, NIC, network interface controller, which means simply a network card, which can be a Ethernet card or Wi-Fi card, anything that interfaces the computer with the network. So if you want to capture, there are multiple options here. You can go to this capture options, and there you can see multiple interfaces are there. Can you see here interface? Okay, so NIC is a network. NIC stands for network interface controller, a card, which is an interface here. Ethernet, Wi-Fi is an interface. Okay, and loopback and Ethernet, these are interfaces. USB. So how do you capture? You can select anything and go start. That is how you can capture. The thing is that the question is, can you capture on multiple interfaces using Wireshark? Yes or no? Yes, you can capture. If you can capture on multiple interfaces, how can you select multiple interfaces? It is nothing but just use the shift click to capture multiple interfaces. Hold shift and click on any interface that you want to capture. To select all interfaces, use shift, to select only desired interfaces, you hold command or control on a Windows and click on any interface that you wish to capture, and then click on start to simply start the capture. So for suppose here I click on this one and start. You see it's started capturing all interfaces that I have selected. So answer is you can capture on multiple interfaces. And I'm reopening the tutorial.pcap. So I don't want to save that file, so here it is. So yes, you can capture on multiple interfaces. What is the correct syntax in a Wireshark to filter the TCP packets for the what chicken? So it is a display filter. How do you write a filter expression? You want to check if that TCP packet contains a chicken or not. What? Remember we learned, go to it. Yeah, so analyze display filter expression. And what do you want? TCP. TCP. You want a whole TCP and you want to check contains. That is the expression. Okay. So we'll see nothing because none of the packets here are having chicken. But you can see here TCP. To select let's say PA, you see, take a TCP, take any TCP packet, okay? This is a data, it's application protocol on top of TCP. Contains you see here I use the TCP contains site stat. It checks all TCP, the TCP protocol, including the header and payload. And you're not checking just do you understand? Hello, can you hear me? Yeah, so it is checking the whole packet. TCP contains, regardless of where it is, header or body payload. And there you see we filtered TCP contains site stat. Give me anything, any packet that has a site stat. It is which is quite different from uh, equal to, less than, greater than. Do you understand? Hmm? We're not we're not we are not checking whether the particular field is equal to site stat or something. We are checking whether this packet is have contains of this information or not. Okay? So let's say that you want to this is helpful if you want to filter the whole pack capture, and if you want to you want to check if someone is logged in with the particular username, Mike. So in such a case, what you can do, you can search in a whole packet. Give me just it doesn't matter where it is. Give me any frame. Frame means you will be checking everything, including Ethernet, Internet Protocol, TCP, and everything. So frame contains site like that. Okay, like that. You see? Okay, this is case sensitive information. Like that. Now this information is there somewhere in TP. Here, welcome is there. Okay, got it? Do you understand difference and how this contains works? TCP contains. Check. The Wireshark detects TCP retransmissions using which of the following method? Sequence and acknowledgement numbers. Yes, we will dig deep into the TCP. Wireshark uses sequence and acknowledgement numbers to find the retransmissions. If you want, let's check sequence and acknowledgement numbers are used in a TCP packet header. They are used for different reasons: congestion control, flow control, and error control. So here you can see retransmission, TCP retransmission detected. So that Wireshark is showing. So let me filter with the TCP. So how come this is how Wireshark detected this TCP retransmission based on the sequence number? This is the column I have added. Go to the transmission, go to here, and you can right click sequence number and right click on. What you can do, apply as a column. That will add a column there in the packet list. So here you can see since Wireshark found that multiple packets with the same sequence number and same sequence number and acknowledgement number, so we flagged them as a TCP retransmission. Okay, so yes, using sequence acknowledgement. Flow start with the implementation to optimize TCP performance as it relates to congestion control. So TCP uses Windows, and say receiving window controls the sender window, and that will be modified as the packets are transmitted. And so slow start was implemented to optimize the TCP performance as it relates to the congestion control. And IPv6, in IPv6, what is the corresponding field in a TTL? So remember, we had a glimpse of IPv6, and so it is time to live. It is called time to live in IPv4, but it is called hop limit in IPv6. We go to IPv6 packet structure, which is different from the IPv4. IPv6 packet structure is fixed. So this is the IPv6 packet structure where you have the version, traffic, flow label, payload length. Next header and hop limit. And hop limit is this is the same thing as a time to live, but here it is called hop limit in IPv6. Unlike IPv4, IPv6 use the fixed length header. And what is the, so you can see here that thing. Let me capture start, capture on Wi-Fi, single one, start, and just start. And take any of the packet, UDP or anything. Here, do you see IPv6 protocol? Can you see that? Yeah. So because my network is using IPv6. And if you go here, this is the header information. Can you see this whole header here? IPv6 header in a packet details. And that header is displayed in a verbose manner, pretty manner. You can see payload length, next header, and hop limit. So here hop limit is IPv. Hop limit is 64, which is much like the time to live TTL in a IPv4, and that is decreased every time it passes through the router. And what do you have here? What is Wireshark? What is Wireshark default color coding for the packets with the TCP errors? And you know that answer, we have seen that already, haven't we? Can you see here? These are the TCP packets errors that Wireshark found in TCP, and which color? So color coding, and you can go to here, expert information, click bottom left corner, and there also you can see some curated information that Wireshark found to help you identify things better. Okay. Now this color coding can be changed if you want. So you can enable this and disable that coloring from the toolbar by clicking on this draw packets using coloring tools. Okay. So which is black, and does DDoS attacks and HTTP flood are characterized by SYN flood. SYN flood is false because synchronized flood is a TCP denial of service attack where continuously other party will send a synchronized request and then but will not establish a connection in order to overload the service or a server. And what is excessive jitter and packet loss does not impact the VoIP call quality. Excessive false, because if there is excessive jitter or packet loss, packets are lost over the network, yes, that will affect the call quality. So this statement is false. Wireshark capture performance is inversely proportional to packet size. Yes, so for suppose what is the packet size here? 92 bytes. Can you see? 50. So see 92 bytes on wire. Here it is shows. This is the size of the packet, 92 bytes. So it means that if the packets are very big, Wireshark needs to do more processing. Less if they are small, Wireshark needs to do less processing. So if packets are big, performance will be low. If packets are low, performance will be high. Wireshark performance. So it is inversely proportional. Which that statement is true. And let's see how we did. Okay. I hope uh, learning through the quiz is helpful and help you to understand and fill the gaps wherever you have the Wireshark.